Alright, this is the test setup for the nPM1300 evaluation kit. I've got it sitting in its chassis. I've got it connected to power through this power supply at 5 volts with a USB style connector. You can see the current is at 0.461 amps because it is still charging. It's just running through the preliminary steps of a battery profile, which first goes through a charging phase and then it does a discharge cycle while it's measuring. You can see here some of the batteries I've been testing, and this one is the one being tested right now, and there's a bigger tablet battery over there. Over here I've got these Kelvin probes connected up to this BK precision battery tester, which is a BA6010, and it's got this Kokum battery under test, and you can see that it's measuring 4.166 volts and 74.12 milliohms is the internal resistance of the battery. And of course my Surface over there, which is running the show. So I'm going to take readings from all the batteries on this meter here, as well as the Nordic Semiconductor battery profiling system over here. And I'm going to get a good feel for how much juice these old batteries can supply. So far it's looking very promising that they're all very good, so I won't have any problem using them later on. Now, one of the things about these batteries is most of them don't have a thermistor in them. This one does, which is the middle wire here, but in this particular connector that pin is not connected. If we were using the little JST connectors, I could connect that thermistor up and it would be monitoring the temperature as well. However, I'm just using my handy dandy thermometer here to keep an eye on the temperature. This little thing here is a thermistor that I could add. There is a place here to connect up a thermistor, but I could add a separate thermistor and monitor the temperature if I wanted to. But so far, at the currents I've been running these things, they're not getting even warm to the touch. So that's not a big concern of mine right now. I'm really more interested in checking out the battery capacity. But that's the rig, and that's how we're doing the testing. nPM power-up module or utility from Nordic Semiconductor. Now this gets started by running the NRF Connect for desktop, and it has a little button to open the nPM power-up module. So to get started in here, we have to make sure that we've got the nPM 1300 evaluation kit selected. This is the one that we are connected to with the USB connector. And we've enabled the fuel gauge, and this says that the battery is close to empty, but we have to set up the charger characteristics, because that's to get it charged up. We want to go to 4.2 volts because this is a nominal 3.7 volt battery, and it's I believe it's a 530 milliamp hour. So we can set the charging current to 530 milliamps, roughly. Now, I want to find out if this battery already exists in the database here. So we'll go and down and look through the Renata batteries, because this is a Renata battery. And we can look at the models that we have available. This one is a ICP 622540. So that is not, oh, there it is, 622540. And it says it's a 600 milliamp hour battery, even though on the battery it's marked 530. However, we can select it and we can write these characteristics into the nPM1300 evaluation kit. Okay, so it has applied the battery model, and so this could be a little higher than 532 milliamps to speed things up. So what I want to do right now is charge it up, because it's 5.4% of the battery left, and the voltage is down at 3.63. So normally I would just enable this, and it says now time to full is 46 minutes. One thing I want to check is the thermistor, because I haven't really connected it. It does have a thermistor, but because I'm using a different connector, it doesn't have the right connection for the thermistor. So I'm going to ignore that and just keep an eye on the temperature of the battery. I have to go back here and turn the charger back on. So it says over here that the voltage has jumped up to 3.81 volts and the current is 460 milliamps. And it's climbing up a little bit, 497. On my power supply, it has stayed constant at 461 milliamps. So that's how we get started with the charging. Once it's charged up, we want to go over here and profile the battery. And when we do that, it will complete charging if it hasn't charged up, and then it will sort of request that you disconnect the power supply for the charger. And then it has a little rest period, and then it starts its discharge cycle and measures the discharge cycle, taking readings as it goes. So I'm going to show some of the batteries that I've already profiled, and we can let this thing run in the background. So to do a profile of a battery, we would hit this profile battery button, and now we need to make sure that things are set up properly. So we've got the battery name, which I have to type in, the terminal voltage, the cutoff voltage for the test. We're going to go with 3 volts just to be safe. That's at the knee of the discharge curve, so at that point we might as well recharge the battery. The capacity here is 600. We can actually make that exact 600, and we'll make the charging current 600 as well. And we will ignore the thermistor. Now this part number is an ICP 622 540 PMT. So now we need to select a folder to save that in, and I'm going to use the same name. I've already created the folder. It should be around here somewhere. Here we are, ICP, this one, select folder. Okay, so it says make sure the battery is at room temperature and continue. And then it brings up this battery profiling screen. It says it's in a constant current charging mode until it completes the charging of the battery. And once it gets there, it will request that the charging connector be disconnected, and it will rest for 15 minutes before going into the discharge profiling and recording. So you do need to be around to turn off or disconnect the charging connector after it finishes charging up. But once it has started the profiling, you can walk away for 2 days. It actually gives you an estimate of how much time it's going to take. This one is going to take another 40 minutes or something to charge up. It does not actually tell you this on this screen, but on the previous screen I had it calculate how much time it would take, and it's in that 40-minute range. So while that's going on, I'm going to just display some of the batteries I've already done and show the discharge curves, the various folders for each of the batteries that I've been testing. Let's just go in here to the first one and drill down to the profile. And that last screen there was also a JSON message that could be used to program this profile into a target microcontroller, I believe. I have not experimented with that yet. So in here we have a spreadsheet in CSV format. You can see it pops up here to be imported into my spreadsheet, and I'm just going to click OK because it's already parsed it pretty well. It's showing the number of seconds on the left, the current, the voltage, and the temperature. Okay, so here it is. I'm going to change the size so it fits into that previous window, and what I want to do here is really plot the voltage versus time. The current is pretty much constant all the way, and it's very small, somewhere in the range of, looks like much less than a milliamp, 0.05 milliamps. Wow, that's small. However, I want to create a column for voltage beside the seconds. So I'm just going to copy the voltage here, and then I'm going to select these two and create a plot. The kind of plot we want is an XY plot. And I just want the line. And And I'm going to smooth it just for the heck of it. And we'll finish that off. Let's move the legend over here. Expand this out. And you can see the discharge curve here. And this is in seconds, so it went to 140,000 seconds. So what is that? So 140,000 divided by 60. I get into a formula. 2,300 minutes, which is 39 hours. So this test lasted 39 hours. It was saying that it's 800 milliamp hours for 39 hours. Now the nominal for this battery is 850 milliamp hours. All right, I'm going to try one more just to see how that goes. So this is looking for the profile of this battery. We're going to open up the spreadsheet and import that from a CSV file. Do the same trick with, there are a lot of data points. I guess that's why it takes so long. So again, XY scatter plot. Okay, so we can see that the voltage went from 4.2 down to 3 volts. And it took about 130 some thousand seconds. And this one is 335 million. So what I want to do now is just look at some of the screenshots as we were collecting the data. Oh, I'm going to move these out of the way. Back here. So this was this guy. So you can see I took this screenshot 41 seconds into the battery profiling period, and it was still resting the battery. So the estimated time was still another 14 minutes. So it rests for 15 minutes after charging it before it starts the profiling. Let's see what the next picture looks like. So we can see here it's starting to profile, and it's still at 0 milliamp hours out of the 335 that it was going for. But the elapsed time was 2 minutes 55 seconds in, and it's estimating the time remaining at 1 day, 17 hours, and 16 minutes. And the next one, it has now finished 33.46 milliamp hours of 335, and the elapsed time was 2 hours 30 minutes. Time remaining was still 1 day, 12 hours and 37 minutes. How many more of these did I take? So we've got one more here. 10 hours in, almost 11 hours. It's up to 130 milliamp hours out of 335. Time remaining, 1 day. And the next one. Now the elapsed time is 15 hours. And it had profiled 178 milliamp hours. $206 milliamp hours out of 335, and still 16 hours to go. So now we're at 346 out of 335. That means it has actually more capacity than its nominal 335. And the elapsed time is already 1 day and 10 hours and 32 minutes. And it's still thinking it's got another hour and 49 minutes of battery left before it gets down to 3 volts. And here's what it looks like when it finishes. So the capacity consumed was 350.83 milliamp hours. And we can go to the data to find out exactly how many minutes that took. So 127,404, just doing a calculation here, equals 127,404 divided by 60 is equal to 2123 minutes divided by 60 again, equal to 35 hours and 38 minutes. So this thing took 35 hours to find out that it had a 350 milliamp hour capacity, even though the nominal capacity was 335 milliamp hours. So that's very good news. I've been using the battery profiling system to determine sort of capacity left in these old batteries I have. So this is a list of the batteries I have. I have these 2 Renata batteries. I have 5 of these little ones here at 335 milliamp hours. I have 11 of these other guys that are 530 milliamp hours. I have 20 of these PK cell batteries, which are even bigger, 680 milliamp hours. And I have 14 of these DTP batteries that are 850 milliamp hours. I only have one of these Colcom batteries, 350 milliamp hours. And I have one battery that I took out of a laptop or a tablet, which has 6,000 milliamp hours listed on it, but it doesn't actually have a manufacturer listed. And I don't even have the manufacturer of the laptop or the tablet anymore. That part of it's all in the garbage. But I'll try and test this one later. It's going to take a long time because it's such a large battery. So it's really useful for me to know the remaining capacity in all these old batteries. So far, this one is saying it's 350, which is larger than the nominal capacity. This one that I tested here, this DTP, seems a little less at this moment. We'll see how the others fare. One other thing I want to mention is that when I first did a battery test or a battery profile, despite the warnings that I needed to keep the computer running the whole time and not let it turn off, it still did turn off at about 20 hours because I think Microsoft decided to do an update. So what I've been using since then is a little Cyber Chiclet, which I'll put a link to. This is a little Arduino module that I put together, very simple. All it does is it's a HID device, human interface device, which emulates a mouse, but it doesn't really do anything except a 0 mouse pixels move every couple of minutes. So it does a mouse move every couple of minutes, but it doesn't move at any pixels. So nothing is visible on the screen. But what it does is it keeps the computer awake and does not let it go to sleep. So that's been running fine for a week and no problems. I'll put a a link to my project for that cyber chiclet in the blog. This is a little table of the 5 batteries that I measured the profile of. They're all 3.7 volts nominal voltage. The first battery is a Renata. It had a nominal capacity of 335 milliamp hours, and it measured out at 350, which is a little bit higher. These batteries are listed in sort of the order of age, the youngest being first. This Kokum battery is probably 12 years old, and these Renata batteries are only about 3 years old. But you can see that they all have pretty good capacity. As they get older, it seems to dip below the nominal capacity a bit. The internal resistance here is not terribly accurate. The meter, or the instrument I used to measure the resistance, is very accurate, but these have various length of leads, and in fact the way it worked out is the longer the leads I had going to the battery, the higher the internal resistance showed up, not surprisingly. But they're all fairly low resistance, and that's good. And this is really great that I can actually get a good idea of how much capacity each of these batteries still has. And I have lots of batteries, so I'm going to make use of this instrumentation quite a bit whenever I want to find a battery that's useful in a particular application. I'm not sure my application is the intended use case for this evaluation kit, but it sure worked out well for me. It does exactly what I need in terms of characterizing the capacity in milliamp hours of any old battery. I have a lot of old batteries, and this is going to save me a lot of time from trying to design something to tell me exactly how good they all are. The Nordic Semiconductor nPM1300 power management IC has a lot more capability than my application actually requires. But the evaluation kit and the fuel gauge board meant that I did not have to do any hardware development or any software development, so it really works well for me. I did research a few of the other applications that this PMIC chip is good for, and I'll put some notes in the blog.